Good evening, students. Today in this video, we shall learn about the internal energy and the first law of thermodynamics. So in the previous video, we have already learned thermodynamical system, thermodynamical process, thermodynamical device, thermodynamical uh, variables, coordinates and all. So in this video, we will learn about the internal energy and the first law of thermodynamics. So, what is an internal energy? Internal energy of a system is the sum of energy, that means kinetic energy, possessed by a body or system due to its molecular motion and molecular configuration. So, due to molecular motion, the energy will be your kinetic energy, and due to molecular configuration, the energy will be your potential energy. So, internal energy of any system or any body is the sum total of kinetic energy of all the molecules due to its molecular motion and sum total of kinetic potential energy of all the molecules due to molecular configuration. So, if you sum up all the kinetic energy, that will be UK, and if you sum up all the potential energy, that will be UP. And sum of UK and UP is nothing but your internal energy U. So we have taken the notation U as the internal energy. So in case of an ideal or perfect gas, what will happen? The intermolecular forces are zero. That's why potential energy will be zero. So in case of real gas or perfect gas or ideal gas, internal energy is only UK. That means it is due to kinetic energy only. So in case of real gas, the intermolecular forces are not negligible. You cannot neglect or you cannot ignore. So the internal energy will be U equal to UK plus UP. UK is potential kinetic energy, UP is potential energy. Here one thing is very interesting, that is the actual amount of internal energy of a system can never be measured, or no one can measure, no one can determine. But the change in internal energy can be measured as du means change in internal energy, and that is equal to dq minus dw, which leads to the first law of thermodynamics. Suppose why the internal energy of a system cannot be measured, because suppose a system has 1 lakh molecule, so you cannot get the kinetic energy of each and every 1 lakh molecule. You cannot, as well as you cannot get the potential energy of each and every of 1 lakh molecules. So that is to find out is very difficult or too difficult, and that is impossible. No one can measure or can never be measured. No one will measure and never be measured. So, but change in internal energy, that means kete energy thila, kete finally hela. So final minus initial. So that is change in internal energy. So that can be measured. So that how, and that is possible, and that leads to the first law of thermodynamics. And with the help of first law of thermodynamics, you can measure the change in internal energy. So first law of thermodynamics, let us discuss. The amount of heat supplied to a system means a portion of matter, maybe solid, liquid or gas. Here the system is considered to be the gas. The amount of heat supplied to a system is equal to the sum of the increase of its internal energy and the external work done by it. That means if you supply Q amount of heat to a body, then that amount of heat will be used in two ways. A part of it will be used in increase its internal energy, that is UF minus UI, and the rest part will be used in doing the external work, that is W. So here Q equal to amount of heat supplied, UI is the initial internal energy of the system, UF is the final internal energy of the system, and W is the external work done by the system. Then Q will be equal to UF minus UI plus W. If the supplied heat dq is very small, then there will be a very small increase in internal energy, which is du, and a very small external work done, which is dw. So first law will be dq equal to du plus dw, where dq is the heat supplied, du is the change in internal energy, dw is the external work done. For an adiabatic process, no heat enters or leaves the system. That's why dq is 0. So here if dq is 0, only du plus dw will be 0. So this will be the first law. But in general, the work done in a thermodynamic process, we know dw equal to pdv. So the first law dq will be equal to what? In place of w, in place of w or dw, we will write pdv. So dq equal to du plus pdv. So this is the mathematical formulation of the first law of thermodynamics. The first law here is an example of principle of conservation of energy or law of conservation of energy. That means whatever the amount of heat you will supply, that will be used totally. Part of it will be used in increasing internal energy, and the rest part will be used in doing the external work done. So that is why the first law is the principle of law of conservation of energy. The first law also can be applied equally to all the three states of matter. That means it can apply to solid state, it can apply to liquid state, it can apply to gas state. First law indicates that it is impossible to get work from any machine without giving an equivalent of energy to it. Thus, first law establishes an equivalence between heat and work. First law establishes the equivalency between work and heat. That means from the first law, you'll be able to know, or one can be sure that no one can get energy or work from any machine, from a machine, without giving an equivalent amount of energy to it. That means you cannot get more work by supplying less heat. Always the work done will be less than the heat supply. That is the first and very important thing of the first law of thermodynamics. Isothermal process. Applications of first law. So in isothermal, in this process, there is no change in temperature and hence no change in the internal energy of the system. So U equal to constant, so du equal to 0. So the mathematical formulation of first law will be what? dq equal to du will be 0 plus pdv. So isothermal process is that process in which temperature remain constant. If the temperature constant, then internal energy of the system will be also constant. That means du equal to 0. So we know dq equal to du plus pdv. So du will be 0. Then dq equal to only pdv. In adiabatic process, what will happen? No heat enters or leaves the system. That means dq equal to 0. So in place you write dq equal to 0. So only remain 0 equal to du plus pdv or du equal to minus pdv. So this is your adiabatic process, and the first law will be du equal to minus pdv. Negative sign indicates that work is done on the system at the expense of internal energy, which is seen in a cycle tube. If you remove the air, then you will feel the coolness or temperature decreases because external work done by at the expense of internal energy. Then cyclic process. In the cyclic process, what will happen? The system returns to the initial state or original state. That means there is no change in internal energy of the system. That means du will be 0. So dq equal to only pdv. Isochoric process. In isochoric process, volume remain constant. In volume remain constant means dv equal to 0. So first law will be dq equal to only du. The heat supplied to the system increases the internal energy and has the temperature of the system, not the volume. Isobaric process. In the isobaric process, pressure of the system remains constant. So the first law of thermodynamics will be dq equal to du plus pdv. So in the next class, in the next video, we'll study about relation between molar specific heat Cp and Cv. For this, now it is okay. Thank you.